Students often feel uncomfortable with problems involving divisibility and remainders. In this lesson, you will master these topics as well as problems relating to prime factors. Well, first, prime numbers. Prime numbers are positive integers that are divisible by only two different integers, 1 and the number itself. Now, there are two numbers you must pay attention to when you talk about prime numbers. Integer 1 is not a prime number because it is not divisible by two different numbers. Integer 2 is the only prime number that is even. Other prime numbers are all odd integers. Now I'm going to pause this video and I want you to write down all the prime numbers less than 100. This will prepare you for some prime number related problems. Okay, good luck. I'm pausing it now. You have 25 prime numbers that are less than 100. You must be able to regenerate this prime number list before you start my problems. Now, factors are any numbers or variables that are multiplied together. In other words, factors are any numbers or variables that can divide the subject number. Well, factors do not have to be integers. Lots of students and even teachers get wrong ideas about the definition of factors. And lots of practice problems out there ask you this way: how many factors of 20 are there? This is a wrong question if the answer is other than infinitely many. Let me just give you one of the infinitely many possible factors of 20. Square root of 15, for example, is a factor. Why? Because square root of 15 times 20 over square root of 15 is 20. When you have a variable expression such as 20 equals x times y, x and y are factors of 20, but x and y can be any number, including complex numbers. So the question should have stated, how many integer factors of 20 are there? Or a little more professionally stated like this. Then the answer is, there are 6 factors for 20. For SAT Math problems, all the problems are asking you specifically for integer factors. Well, they may not be using the term integer factors, but they phrase the question so that they do mean factors that are integers. Now, prime factors are factors that are prime numbers. Well, my question to you, is 1 a prime factor? Well, 1 is not a prime number, so 1 is not a prime factor. So prime factors of 20, for example, are 2 and 5. To find factors and prime factors, you can use either a short division method or a tree method. For instance, to find factors or prime factors of 120, let's use a short division method. We must use only prime numbers to divide 120, as you know. Divide by 2, you get 60. Again, divide by 2, you get 30. Again, divide by 2, you get 15. Divide by 3, you get 5. That's it. You cannot further divide. So the prime factors of 120 are nothing but the numbers you just divided and the last number you see here. So the prime factors are 2 and 3 and 5. Now, by looking at the short division we just did, 120 can be expressed as 2 times 2 times 2 times 3 times 5. Now, factors of 120 are all possible combinations of 3 2s and 1 3 and 1 5 here. And I'm going to pause this video again. Please list all the factors of 120. Good luck. Here they are. If you missed one or more, make sure you understand why you missed. Now, this is basically what you learned in elementary school, but bear with me. Reviewing these equivalent statements regarding the remainder after division will really help you understand what I'll be explaining in a few seconds. You know that 7 divided by 3 is 2 plus 1 over 3. If you do this long division, it goes like this. So we say 1 is the remainder when 7 is divided by 3. When you divide 6 by 3, you get a remainder of 0. In this case, we say 6 is divisible by 3, or we can also say 3 is a factor of 6. All these statements are saying the same thing. Well, to summarize, the statement saying that the remainder is 0 when you divide x by y is exactly the same statement saying x is divisible by y, which is also same as saying y is a factor of x. And I want you to be very familiar with these equivalent statements. Now, this lesson about the remainders is one of the most useful tools to solve this divisibility and remainders problems in SAT. You can consider this method as a shortcut. And here we go. Lesson 1. When x is divided by 9, the remainder is 5. What is the possible value of x? Well, the smallest possible number for x we can plug in is 5. If you divide 5 by 9, you get a quotient of 0 and a remainder of 5. Now, to get the next number for x, you just need to add the number that you're dividing x by. That is 9 in this case. So if you divide 14 by 9, you surely have a remainder of 5. So if you keep adding 9 to previous terms, this arithmetic sequence represents all possible integers for x. Now let's move on to lesson 2. When x is divided by 9, the remainder is 5. It's the same question. What are divisible by 9? Write the answers in terms of x. Well, let's try one number for x. Let's try 14. If you divide 14 by 9, you get a remainder 5. This means if you divide 13 by 9, you get a remainder 4. If you divide 12 by 9, you get a remainder 3, and so on. And finally, if you divide 9 by 9, you get a remainder 0. Well, what can you conclude from this? Well, going back to our question here, if x is divided by 9 and the remainder is 5, then if x minus 5 is divided by 9, the remainder would be 0. And all these numbers form an arithmetic sequence with a common difference of 9. Of course, all these numbers in the sequence must be positive. Well, this is going to be an extremely useful tool for solving some medium hard to hard problems in SAT Math. Well, originally this was not a part of my lesson, but when I was talking to my niece, who is an 11th grader, and told her how she could easily find the remainder using a calculator, she was going, "Wow, nobody taught me how to do this." And she insisted that I put this on the website. So here we go. Actually, nobody taught me how to do it. I just figured it out, and it's pretty simple. Let's say you're dividing 237 by 7 and try to find the remainder. Well, if you don't have a calculator, this is what you do, and the remainder is 6. But when you have a calculator, please don't do this. You don't have to. Just punch 237 divided by 7 and you get 33.857 and so on. And subtract 33 from here and multiply by 7. And voila, you get 6. And that is the remainder. Okay, let me explain why it works this way. Well, this 33.857143 can be written as 33 plus 0.857143 And at the same time, 237 divided by 7 can be written as 33 plus the remainder over 7, as you can see in the long division. That means r over 7 must be equal to this 0.857143 and so on. So to get r, which is the remainder, you just multiply this decimal by 7. Now, do you understand why it works? Okay, let me summarize. To get the remainder with a calculator, this is what you do. After you divide the number using a calculator, subtract the integer part and multiply that decimal by the number you're dividing by. You get the remainder right away. Now you're ready to solve problems. Let's begin.